Everybody comfortable? Yeah? Okay, I wasn't sure whether it fits everybody. It looks like everybody's got comfortable, or nearly everybody's got comfortable chairs. We've actually bought some folding chairs for the user group. How many people, just a show of hands, how many people is it the first time you come to the user group? Okay. All right, excellent. All right, well, we've been running for well over a year now. I remember the first one was around the couch, and there's like 3 people, and then 3 people from my team. We've expanded out quite a lot now, and it's really starting to pick up as a group. We had a big one last month with Jose Balin. For those of you who don't know, he's the god in the Elixir world. And he's very keen to come back to Barcelona as well, so I'm going to be contacting him and trying to get him back again. Another show of hands, how many people are on the Slack channel, the Elixir Barcelona Slack channel? Okay, all right, great. Well, those of you that aren't, it's not a very chatty group, but it's mainly where we push out the announcements and the dates, and sometimes I run polls and stuff like that, but if you haven't joined, please feel free to join. It's not the Elixir group within the Barcelona channel, it's just it's called Elixir Barcelona. And I'll be linked to it in all of the meetups, but if you want another link, if you can't find it, just post something on the meetup and I'll send you the link. Okay? Today, we're going to be having a talk from one of my developers here. By the way, I'm Zian, I'm the CTO of the Book of Everyone. If you have some questions about this company later on, I'm more than happy to talk about that. But today I've got one of my developers who's going to be talking about distributed Elixir. It's his first time talking, and he's got quite a task. He's jumped in at the deep end, but we've got a very friendly crowd here. And we're also going to try and stream some of it. Is Ricardo now there? Or no?
Yeah, I think so.
He is there?
Yeah.
Okay, fantastic. So feel free to ask questions. I think not too many because there's quite a lot of slides, and we want to try and keep it to about an hour or so. Okay. All yours.
Okay. First of all, if anyone has any question at any slide, just ask, because if you have a question and it's not solved, maybe you can get loose on the slides. Okay. So first of all, after talking about how to create a cluster of Elixir nodes, I think it's a good point to begin talking about how the code is structured and executed inside the Erlang virtual machine. Both Elixir and Erlang have applications which are the structure in which you can put your code inside to run in processes that run inside the Erlang virtual machine. These processes are lightweight processes which run inside the Erlang processes and not in the operating system itself, which is better for us to create distributed applications because it allows to just spawn new processes without taking care of how many cores has the CPU, the machine, or the operating system itself. An important point which we are going to see during all the presentation is that the processes are identified by the process ID, the PID, and they can also have a name assigned. A name which we are going to use to send messages to a process, because the PID can change every time. How we can communicate between processes using messages. The Erlang virtual machine is based on message passing, which help us to have synchronous communication and avoid unneeded blocks between different processes, unless we explicitly tell the virtual machine that we want to wait for an answer. Also, it allows to have isolated processes, which means that if a process crashes or enters in an infinite loop, the rest of the process inside the virtual machine can continue running without noticing any problem. Also, it helps to have processes in virtual machines and fits very well with the idea of passing messages using network messages or packets in our local network, inside the same machine on different ones. As I said in the previous slide, the messages can be sent to a PID or a name, which at the end is a PID. Now, first demo. We are going to have quite a few demos of all of this. So, if I start a console, as I said in the first slide, everything in Erlang is a process. So we can check the PID of the console using self, which is a function we can use in any time to know the PID of the running process in which this code is executing. We can use spawn to create a new process, for example. You can see that this new function is printing something on the screen from a different PID, the number 87, when the console is the 84, and every time we launch a new one, it's a different process. Also, to see the message passing, I have created a few examples which are in GitHub, and I'm going to post at the end the URL so you can check them home if you want. This is a ping server which waits for ping messages to answer with a PONG message. At the moment, we can avoid this part of the global module, this error. Just take care of the spawn link. Spawn link is like a spawn, but if the process fails, it returns an exception in the process that launched this process, and it executes a loop, waiting to receive a ping message. When it receives one, puts the PID of the sender and responds with a PONG. And in the server side of this ping server, we send a ping message and waiting during a second for a PONG message. If in a second we don't get an answer, we say that there is a timeout. We can check it here. We try to ping the server without starting it before. We get an error, the application is not started. If we start the application, the server, okay, it's started. We can now make pings and get PONGs in response. Okay, these global calls are to assign a name to the process. We can assign the name ping and use the name ping to get the PID to which we are sending the message. We can also use it to know when the application is not started or when the application is already started. If it's already registered, we can know that we have at the moment in our instance, in our Erlang instance, a process running with the same name. But we can try to start it again, and it gives us the error already started. Okay. Now, we know that we can create.
La process is always the rules of the VM.
You can scope it locally. Yeah. We are going to see it later. This is only for the demo purpose because we are going to use this code later on different nodes and it needs to be global. So we know now how to run processes, communicate between them in the same instance of the Erlang virtual machine, but we need to, the next step is to connect the different nodes to create a cluster in which we can run our different processes and communicate between them. So the good point of all of this is that Elixir at the end is running inside the Erlang, and Erlang has been historically used for distributed system, for example, for telephone networks, which means that it has a well-proven technology to make distributed systems and run over the network. But how can we do this? First, we need to complete at least these three steps. Set a cookie, specify the node name, and obviously connect to between the nodes. The cookie, well, this is optional when we are running on the same machine, but if we are running different ones, it's mandatory. It's a secret key to avoid unauthorized connection to our clusters. This is a secret key in which we are storing without encryption or anything in that file, .erlang.cookie inside the home of the user that is running the process. We can also set it passing an argument when launching the Erlang or including it in a vm.args file. This file and another one called sys.conf are usually used on deploying when we are going to deploy our application to write the exact configuration in that file and making it persistent between different deploys of the same version. It's also used when we create releases to put it into the release so it cannot be changed. As I said, when the nodes run in the same machine, you don't need to worry about this because the file in your home directory, which is created automatically by Erlang, is shared between all the instances. Then another important part is giving each node its own name. The node name structure is a name, which is a literal whatever you want, at a host. And that host is very important because it has to be discoverable through the network. It can be an IP address, it can be an internal DNS, an internal domain name, or just a host name that can be discoverable by your machine because it's in the host file or something.
Does it make any sense to have hosts, different hosts that are connected only to the internet, not local?
Yeah, you can do that if you want. Yeah, and put just the IP address and in the host part, put the external IP address, and if the routing is in your firewall is correct, you can.
And it's secure by default, SSL
No.
or anything? Or?
No, by default is I think it's not encrypted, so.
You have to handle it.
Someone asked me before, and I didn't check this. I think
We need to set up a VPN outside the internet.
You said it yourself, no?
Yeah.
I don't know if it can be configured in Erlang or not. I haven't done it.
I don't think it's not really.
Yes, probably you have.
Configure that in the Erlang machine. You have a VPN, software dedicated to that. The Erlang just communicates and doesn't know that it's controlled.
If you are using Docker, you can create a dedicated network only
You can also set a short name, which is the method I'm going to use in these demos, which is just the name part, and Erlang autocompletes with your host name at the end. This configuration can also be set on this vm.args file or using parameters. This leads us to EPMD, which is the internal service that Erlang uses to discover nodes over the network. This is the one that needs that this host part is discoverable, and also allow the cluster to auto-discover different nodes, which means that if you have a new node that connects to one node in the cluster, automatically connects to all of them, because it's needed to pass in messages between. It's not a peer-to-peer network, it's all the nodes connected with all. It's very important that this service is running on port 4369 and needs to be always that port on all the nodes, because it's the one used to connect to different. When you try to connect to a node, the first thing is this software connecting to the same software in the other machine and asking what are the instances you're running in this machine. Then the configuration ports. By default, I think Erlang gets random ports if you don't configure any range of ports to use. But it's very recommendable to configure them, because if you are going to expose your instance to the network, it's a good idea to put some firewall rules to avoid only communications from your host or something. And also, we need to remember that the port of EPMD needs to be open. And this is a full example of a command line to run Elixir with all the configurations. Which is in this example is the complete name with the host name, the cookie for security, and these parameters that are passed directly to Erlang. This flag is to pass that parameter directly to Erlang. Okay, now we're going to try all of this. Okay, how that is really good. Okay, so we can start a node called foo. We can see now that the node is foo at Skynet. Skynet is the name of my computer. Okay, let's like this. Name bar. We can use the node module of Elixir to connect to our nodes and see the list of nodes we have connected. At the moment, none of them is connected to each other. We can try to connect to itself. It's going to work, obviously, because it's already connected. And also connect to the other one. All that are connected, we can check the list again, and it's connected. Here, Meetup is connected. And if we create a third node, and connect to one of them, we can see that now it's connected to all the clusters, all the nodes in the cluster. Okay. The cookie configuration. which is just a string. You can create a string as long as you want. Okay. If we now try to connect from a node which doesn't have the same cookie that the other one, we can see that it fails, and here we can see an error of unauthorized attempt to connect. The right cookie value, it can connect. So it's just like a password for connecting to other nodes. About the EPMD software, we can see which nodes are discoverable at the moment by calling this method. No. Is names, I think. Which gives us the configuration that APMD has in memory, which is we have the foo node at this port and the bar node at this one. If we have a remote node, it will appear with the IP address and the port.
You have to launch the EPMD.
No.
It started with the
Yeah. If you set another name, it is automatically started with Elixir and Erlang.
There's no that starts.
Yeah.
Is the one that wins. The second node tries to start new ones.
With the same name, you mean?
Already started and once. So it's already one start.
With the same name, you mean? Because you can have all the nodes you want running in the same machine if they have different names.
No,
No, it only launches one instance of EPMD. Yeah. In fact, if you have the firewall activated in your computer when you launch Erlang with some of these parameters for networking, the first thing is EPMD tries to accept incoming connections. So, okay, so this is the basics about connecting nodes. Also. Now, we know how to connect the nodes using the configuration, but it's very important to have in mind how this looks in the logical part of our application, which is very basic, and is that everything is inside the virtual machine. We can communicate to processing machine instances that can be in a machine in the other part of the world without doing anything, just passing a message to its PID, and Erlang takes care of everything. Which is basically something like this. In the physical part, we can have a lot of servers, but in the logical one, it's like a cloud in which all the processes can pass messages one to each other, and there's no, well, there will be some delay, but nothing that is to worry. Now, how to connect the nodes themselves when you are already running Erlang virtual machine and you have configured it correctly. We can use node.connect, which is the one I used in the demo, just specifying the host. You can create a .host.erlang file, which you can specify the host one per line, and call this function netadm.work, which tries to auto-connect to all the hosts in that file. If, for example, during your deployment, you read from Amazon Web Services or Kubernetes API the list of hosts, you can put it in that file. During the startup of your application, call this method, and that's all you need to do.
if you connect to one host and you're auto connected to the rest of the host, you need to have more than one host in your file.
Sorry?
If you are connected automatically to all the hosts,
Yeah.
you connect to the first. Do you need to have more hosts in the host?
No, sorry, you can have only one, which is in the cluster, and your node is going to connect to all of them.
So you have only one host, but then
Yeah, you can have multiple, because if one fails, it tries to it tries to connect to all of them, also applying the auto discovery part of the connection. Also, we can use the sys.config file, which is another configuration file for Erlang, in which you can specify a list of hosts and also specify if they are mandatory to connect or not. If you specify a node that is mandatory but it cannot connect, it will fail and the application crash. And also use custom scripts or library like this one I put here, which allows to connect during the application startup to the Kubernetes API, get all the nodes which have a specific tag, and connect all of them. It's very useful if you cannot know the IP address that your nodes are going to have. Okay, another demo, which is the ping application I showed earlier. We said that it has a name registered globally. So if we came here, let me check that are connected. Okay, this is not running application. Now I can connect to the node. Okay. They are connected. Now if I try to do a ping without starting the server, it gives me an error. I go to the other node and start the server. Link. It's started, and from here it works because the node name is registered globally, so it is able to, from the ping name, gets the PID, which is in the other side of the connection. And when it sends a message, it goes through TCP from one instance to another, and it's a response. I have said that processes are available in the PID are accessible from anywhere, and they are, but the application names not always are available. It depends if you want your process to be in a local environment or in a global one. That's why in here I use the global library, because for this example I need I need the ping name to be global. And this connects with how we can find processes inside our cloud of Erlang. As I said before, each process is identified by its unique PID, and can also have a name which is assigned to the PID using a key-value storage, name to PID.
If you start a node and you work a process from there,
Yeah.
and then you connect to a node that also has done the same, and they happen to have used the same PID, it will solve the conflict.
With the name, you mean?
No, with the PID.
The PID.
The number.
No, because the PID number.
It's prefixed.
Yeah. If in fact you can see here that the ping server is 0.273. But if you do here global dot where is name? Ping. It gives a different one because the first number in the PID identifies the node which is running. The same process in different machines is almost the same PID. Okay. So the process name is an atom that can be an actual atom, which, as we know in Elixir, or also a module name, which in Elixir is also an atom, and can be registered locally or globally, as I said before. Globally using the global library, and locally using the registry available in Elixir.
So in the case of names, when you spawn a process and you create a name, it's in the local scope, so it's not going to conflict with the name because it's in the local scope.
It depends if you use the global.
What happens if you use the global keyword?
The global library has a way to indicate a function that it used to resolve this kind of conflicts. By default, I think it gets the latest one. I think.
So there's a
That's in the global module documentation of Netherlands. You can specify a resolving function to this kind of basis. By default, it doesn't give you an error, and that's why here in the code I check first if the name exists.
Okay.
Because that's the only way to do that. Well, the global library included in Erlang, which has these three methods to register and find PID using the name. It works out of the box. You don't need to do anything to initialize it. So yes, Erlang takes care of all of this. The Elixir registry, which is available from version 1.4, it's a local registry because it uses ETS tables. Between, among other things, is because it uses ETS tables, which needs to be attached to a process, and a process is local to a node. But it's more flexible when you have to create complex names. It allows you to specify the names as strings, so you can create it at runtime. It's more flexible than using atoms, like in global. Now some libraries that I think are very useful. To create distributed applications. First of all, obviously Gen Server and all its derivatives, which works out of the box in distributed environments, because it allows to register a global name without almost doing anything, just changing an argument. And it's based on the idea of passing messages between the client and server, so it's perfect for the job. At the bottom, it relies on the Gen module in Erlang, which takes care of all of this, and it's a very proven module. I have an example here, a very basic calculator running Gen Server. It's an example of a Gen Server that you can find in any tutorial on the internet, but the only thing changed is that here I assign the name, which I tell the Gen Server it's a global name, and the atom I'm using. Using this kind of tuple here, Gen Server automatically registers the node, the process name inside the global library. Also takes care of not having duplicates running, and okay, here calculator. So, okay, it gives us an error because there is no process running. It's that name. We now start here at the server, and now the sum works. But if we try to start another one, it's already started with this PID. And all this is out of the box with the server.
If you have two new nerds, you studied on each of them, you try to join them together.
Sorry?
If you studied, you have two blank nerds, you start the application, when you join the nerds, they will each have the application and will be running some work with them.
I don't know. Probably one of them dies, but I don't know. I suppose that use the global library, which has a resolving function for this kind of things, but I have not tried. Because another thing that is very important when creating distributed applications is trying to connect as soon as your application is running to avoid that kind of content. Okay. Also, I don't have it here. But if we look at the Elixir documentation of Gen server, yeah, it has a pretty good documentation about name registration of the process. The global one, which use the global module, that's I suppose, and you can also use VIA to use a Elixir registry. Okay, this is the demo. Okay, now all of you know what is a supervisor in Elixir. If we are working with processes, most of the time we want them to be supervised. And when we are working in a distributed environment, it's very important to take care of what happens when a node dies. This means that if one node dies and is running a vital process, we need to be able to know that that process is not there, and we need to start it again, which is usually what a supervisor does, but not in a distributed system because they are thought to supervise only local processes. So a possible solution for this is a small library or implementation done by Ricardo, which is one of our remote developers, and by Lacoste, which is there, in which each node has a supervisor. Each supervisor tries to start the node when the application starts. And if the node is already started, it needs to take care of what happens if that process dies. But as I said before, by default, it cannot work on distributed systems. So there are two possible solutions. One is monitor node changes in our cluster, and every time a node disconnects from the cluster, try to start the application again. If it fails to start the application, the process is already running because it's registered and we can communicate with them. If the process dies, the first supervisor who tries to start the process has the process running in its instance, and it will be running there. The other option, which for me is better than the first one, is to link the worker to all the supervisors. So if the node disconnects or the process dies, all the supervisors are notified and all of them try to connect again.
One question. We didn't have these two options.
You have these options?
We didn't have.
You didn't have.
Like in that one, we just restarted the settings and that's all.
Yeah.
So why do we want this second option?
The second option is because we need to know when a node disconnects that is running our process, we need to know it to start it again. So if we link it to the supervisors are notified that the process died, and they can start it again. I don't know if that answers your question.
So like in Erlang, in this sense, we didn't have supervisors.
You don't have supervisors in Erlang?
It's probably a question.
I don't. I don't know. In fact, I don't know. I don't know if there are supervisors by themselves in Erlang. Anyone knows? Yeah. Well, if you want to take a look at the implementation they did, it's this link. I'm going to share it later on the slide. So another important, or probably that you will probably going to use if you are using a distributed application, is creating a pool of workers. Because it's very common that if you create a distributed application, you want the workload to be distributed equally in all your nodes to avoid nodes more loaded than others. There are two ways of doing this in Erlang, two main ways of doing this. You can also use minor libraries. But well, the first one is pool, which is a native Erlang implementation included by default in the Erlang runtime system. But this one creates a pool of nodes, not processes. So it takes the node with the lower load and execute the function you need on that node. I think this is more equal to maintain the same load on all the nodes of the cluster because it only takes care of the actual node load instead of having a worker free or not.
I didn't get the second part. So, what do you mean with a node with a lower load?
Yeah, lower load. When you create a pool of nodes, they push the load, which is a number between 0 and 1, to the master, which is the one who decides who has the lower workload, and send the work to the node that is more free. The bad thing of this is that it has one master node, and if that master node goes out of the cluster, the pool dies, and you need to create it again. The other option is Poolboy, which is a third-party library for Erlang, which runs locally in a node, and it allows you to have a pool of processes to do some tasks, like gen servers, for example. The good thing about this is that you can have different strategies. Like, okay, I need to have 10 processes running all the time to keep one when I need one. And if all of them are busy, I can create another 3 or 4 more to extra load. The second link is a pretty good and pretty old tutorial about using Poolboy in Elixir, which is pretty hard to find examples of Poolboy used in Elixir. Okay, now we know to create processes, how to distribute it over the network, find them, send them load, works. But most of the people that use Elixir nowadays, I think, is for web development. So how does this work with Phoenix? By default, Phoenix has a pool of workers which attends the HTTP request. It creates one process per connected channel. Every time a channel client connects, it creates a new process. And there is a parent process to all channels, which is the pub sub application. But when we connect a cluster all by itself, you don't need to do anything. Each node continues attending their own request. It means that the load generated by HTTP request is not distributed over the network. But the pub sub processes of all nodes are monitored by themselves, by all nodes, which means that you can use the channels. You can access any channel from any node. This is very convenient because if you use channel, for example, for a chat application, and you have 3 nodes, you need that a message sent to the first node needs to be distributed to all the open channels in all the nodes to have the same version of the conversation in all of them. And it works out of the box. You don't need to do anything for this. It just
So is the upside process like global? Do you
no.
address a specific one?
No, you have one in each node, but then there is an Erlang application called PG2, which takes care of monitoring all the nodes, all the pub/sub application on all nodes, and exchange messages between them. So you can, when you create a broadcast message for all the channels, it is sent to all the pub/sub process, and each pub/sub process sent to all the channels.
That's peer-to-peer, right? You don't need to host that in a specific.
Sorry?
That's peer-to-peer, right? You don't need to have that working on a specific node.
Yeah,
They'll all connect to each other.
exactly. Yeah. Now, a very useful tools for when you are doing distributed applications is the inspecting tools, because if you start to play with different processes in different nodes, you are going to start to have a mind blown with processes running here, running there, how they connect to each other. So I mentioned the three most useful, at least for me. One is the observer application, which is inside Erlang, in which you can get info from processes, messages, load, get backtrace of running processes, get information about nodes. Let's see it in action. It takes a while to load. Okay, for example, here I can see that I have two nodes connected. I can change from one to another. You can see the load charts, memory statistics, applications running in each node, the processes, the message queue in each process. This column is especially important if you have problems with the with bottlenecks with processes, because if a process is very slow, you can see the message queue going down. Also external ports out of Elixir, which doesn't have to be especially network ports. It's also opening files and calls to external programs, these kind of things. Okay, so the next one is Web Server, which was presented in one talk of the Elixir Conf here in Barcelona. Well, I think that it's presented before, but there was a talk about it. It was created by a member of the Square Enix team, I think, and it allows to do the inspection like Observer, but using a web interface. You can also access a JSON API to get information, and well, let's start this. Okay, now connect to the other node. Okay. And now here, this is the web server, which is more or less the same that you can have in the server, but you can access via web, so you can have it in production if you want. I wouldn't recommend that, but you can access a production node of server from your browser. Having it in production, because you have to be very sure that it's protected. Because here you have a lot of information about your application. For example, if we saw the application itself, yeah, we can see a lot of processes. These ones are the Phoenix process for HTTP requests that are just web workers, which depends of the web endpoint itself. And here we can see the pub sub in which the channels are spawned.
Can you do data side on production, just the monitoring?
What?
So you do data side on production?
If you use it in production, you need to put some security, but you can enable it just for IP address or something.
Yeah. It wouldn't slow down the application.
But if you want just to monitor, you can use specific libraries to send information to Grafana or some kind of, which will probably be better. This is just for when the problems came. What? The
state of the process.
the
Like an observer, you can check the state of the process.
Yeah, you can see it here.
The wrapper.
It's a web wrapper around the observer. Okay. Yeah. Oops. If we start the observer, the application itself, it's a standard Phoenix application. Here, applications, distributed Elixir, and we are now connected to the full instance. It was the first one I started, so I need to change to full. And here we can see the channel, which is linked to the pub sub, and also the pub sub itself. We can see it's monitored by one process that is running locally in this node, and one process that is running in the other node, which is the P2 process that takes care of sharing messages between different channels. The last one I want to show you is the Erlang Performance Lab, which is not intended to be for Elixir, but as Elixir running Erlang, it works well. I don't have it running here because it's a bit tricky to configure it, but we can see a demo of how it works. It's a web interface in which you can see the status of your cluster. You can see all the connection between nodes. You can see how the messages are sent between nodes. This is pretty visual.
So slow. Those messages.
You can also see the process, the messages sent to the process inside a node. Well, this can be good to detect some performance issues. For example, when you have a lot of messages go to just a node because you are not doing well the load balancing between the nodes of your cluster. But this is probably the latest thing you will do when you are creating a distributed application. It's the last step. So, and some references which I think can be useful, and that's all.
Okay.
I hope this is enough for start playing a bit with distributed applications.
Do we have any questions?
What about PG2? I don't know if you can answer or not. If you've got messages like in Phoenix, for instance,
So if you've got channels being synchronized via PG2, does it manage the sequence that they're applied at each channel? So if you've got the same channel running in two different nodes.
You shouldn't have the same channel in different nodes, because when you connect, you use the TCP connection used for HTTP request. So it doesn't, it's not shared between nodes, or it shouldn't be. When you connect to a node, normally you go through a load balancer, which gives you the connection to one of the nodes, and your channel is there.
So you would never have the same channel running in two?
You shouldn't. Well, you can have the same channel itself, the same room of the channel, but not the connection to the client.
Right, so they run independently?
Yeah.
Okay. I misunderstood.
So the PG2 application is running in all nodes, but it shares messages between the cluster.
Right.
It's like a broadcast application.
You're routing to the right node.
Sorry?
It's routing, no, the message?
Yeah.
To the right node.
Can everyone hear me at the back there?
Yeah.
Very good. Okay. So I'm gonna. This is going to be very fast and a very long talk. You know, you're supposed to only say 3 things in a presentation. I'm going to say about 200 things. So I apologize. This is super fast and super quick. So functional design patterns is basically a brain dump of everything I can think of and squeeze into 60 minutes. So my name is Scott Bloshin. I have a website, fsharp@fundandprofit.com. And F-Sharp Works is a group of people who do F-Sharp consulting. So if you want F-Sharp consulting, come and ask us. Where's my slide? There's my, there we go. So I was a bit hesitant to use the word patterns because obviously there's a lot of overloaded connotations with patterns. So I thought about using practices or approaches or tips or something, but you know what?
There's no one.
I'm going to reluctantly stick with patterns. So these are not gang of 4 patterns. These are just patterns when you do something over and over and you.
Okay, I got it.
So before I get started, I'm just going to give you a little bit about my.
I was thinking it was someone. It was someone on the Hangout channel.
Because I saw that. I always recognize it. I saw that.
Okay. Can you introduce yourself? Yes, I'm sorry. Oh, that would have been really cool.
Yeah.
All right, I've lost all train of thought. What were we talking about?
What was this? YouTube autoplay in the next slide, the next video.
It's good stuff, yeah. That's the, which talk is it?
It's the functional programming.
Yeah,
Railway
Functional program designs by Scott was.
Railway development, I think it's called.
Yeah, it's an F-Sharp guy.
Yeah.
What was the question?
Yeah, and it's also.
Yeah.
Yes.
It's the first one to give anyone learning.
Okay, so.
Where were we? We were talking about PG2, but I think we kind of.
Okay, all right, cool.
Yeah.
I wonder if there is anybody. Is there anybody?
No, there's nobody.
There were 6 people watching it.
Maybe not in the Hangouts.
Oh, it's in the Hangouts. Yeah. YouTube. Okay. Any other questions?
About message spacing, do you have any constraint on the size? Like if you're doing video processing application, will you transmit the whole data through stages?
I don't know if there is any constraint, but if you are passing information over the network, I think it's better to keep things simpler. At the end, they are always basic types of Erlang, so I suppose you can send any kind of object, but you need to, I suppose you can send like a file descriptor or something like that.
A process has to run executes always in the same node, or can one of the
Well, while it's running, by default, it's run only on a node. But the process in Netherlands, they are lightweight process, so maybe if it's a very simple process, you can move the process from a node to another. Because a process inside Netherlands at the end is a big tuple with a lot of information. But I haven't seen it never, so I don't know.
But what happens, for example, when a host dies?
All the processes go die too.
There are no restart again.
Yeah, that's part of this. This problem was about this. So what happens when a node dies and you are running a process unit there? By default, it just dies, but you can create a way to use supervisors in a distributed way.
And we need the application to be installed on the
Or not know the host. Well, yeah, you need to your application running on the host. Yeah.
Imagine two libraries from Magic.
It's pool and poolboy. Yeah.
Do these run on a single node as well?
Yeah, they run in a single node, but pool gives you a pool of all the nodes in the cluster, which at the end is like running it distributed.
Okay, so if any node in the cluster dies, the other nodes can still start more processes. The process that are missing, they can start.
Yeah, they can if the node that dies is not the master node.
Is that right? Because this one
Yeah.
Poolboy also has a master.
Poolboy runs locally, so you don't have a master node. Or
It's not distributed.
No, it's not distributed. If you want to use Poolboy in a distributed way, maybe you need to use both of them. Poolboy in each node to generate a pool of processes, workers, and then pool to call the poolboy of the node that has many lower load.
I guess like the best case scenario is like a bunch of machines. Any one of them dies. There's a rule sign that says I must have 10 processes. If any one of them dies, a random machine has some processes started. If we get with pool. But if the master dies, I'm still screwed.
Yeah.
Maybe
there is a way to do that, but I don't know how to do it.
Yeah. Because with Elixir, said that the upsell, they were peer to peer.
Yeah.
So if any one node dies, then the new request can still be served for something.
Yeah, if a node dies, the channel in the client side in the browser will be notified of the die because the connection is lost, and it will try to reconnect automatically and connect to another node.
But any of the nodes can die.
Yeah.
They weren't promising.
Yeah, that's the idea. Ideally, you will for the pool library, you will run only one global process which starts and waits for the master, and if the node dies of the process die, the supervisor will take care of that and start it again. That's the ideal thing, but there will be probably a lot of edge cases which.
You're always stuck with a tree in the end.
Yeah.
Still got to run the sequence.
Yeah.
Unless it's probably.
If your process die, what happens to the messages in queue?
I think they are lost because they are tied to the PID. Or the message has a PID to which they have to be delivered, and
Yeah, that's one thing they say. If you want to guarantee delivery of a message, you have to unlock these.
message passing, yeah. You need to use a third-party application like Redis or something like that.
So you don't have acknowledgement of messages.
I received
Except
no.
if you don't code it.
No. In fact, you can send a message to an existing PID and you don't know what happened.
So in practice, in that situation, you have one machine.
Yeah, I think it's the ideal thing because if you well, it depends. If you only have one machine, what?
Yeah,
No, not really, because Erlang, when it starts a real thread of the operating system per core. So ideally, one instance of Erlang can use the whole machine.
So
You can do that if you think your code can fail and you want to run different instances and you only have one machine. You can do that. Connect all the instances in the same machine, and if one dies, there are one or two more. But that means that your application can crash. So
It's like a good transfer.
Yeah. Yeah.
So in the production, we use more than machines.
What?
In production, we use more than machines in application.
Well, I think it's the ideal thing. Yes.
But
It's like, do we
Ah.
use more than 2 machines? in production?
Yeah, we have more than two machines.
what is the reason for this?
What?
What is the reason?
What?
What's the reason
Ah,
for having
mainly scalability in our case. Scalability.
scalability?
But why do you not just do huge instances?
We have.
Because they're expensive.
Yeah.
So from a financial perspective, our load can change depending on how many processes we're processing. So it's easy to have lots of small, cheaper machines and add
Yeah.
more cheaper machines to it, as opposed to have 2 big machines. Our load is not constant. So Christmas comes, we need to have more machines to handle Christmas. It's easier to add a machine of the same type as opposed to going away and saying, I'm going to upgrade from being on a really expensive VM to a really cheap VM.
Yeah.
That's how I experience it.
At the end, if you have your server the most small possible, you can take control of how you add more power. More power. If you have huge instances, you are going to add huge instances each time.
So you just
Well,
increase
yeah.
your instances and decrease it.
Yeah, but using small ones, you can adapt better to the load.
That's why you
No, that's a very good point. I mean, you've got that 2 machines, 2 massive machines, so you need to lower your costs. You lower one machine down,
Yeah.
put all of the loads in, and you lower the other machine down. For us, we just kind of had boxes and we just
Add
line
more.
them all up, or we strip them all back. It's just an approach. Yeah. Somehow, yes. So we've got various different processes that goes away and works out load, and then adds more instances when it thinks that it can't cope with stuff. We often go in there and realize that we've got a whole bunch of instances and cut them all back again. It's not, our spikes in people coming are fairly predictable, so we don't really have to monitor it. We know when Christmas is, right? It's not kind of, every so often you might be in a newspaper or on TV or something like that, but we generally know when we need to increase our capacity. Yeah, it would be great to get to a situation where we just don't have to worry about that. So at the moment, it's not really a problem.
So if you did have to worry about automatic scaling, what Elixir tools would you use to figure out? Could you just listen, right?
The current load.
Yeah, like the average load of everything else.
Yeah, you will probably can use some auto scaling tools from your cloud provider.
You'd have to get a path that you could get. The tool you showed us earlier. It looked like
The web server.
Yeah, it looked like it was getting like the
Yeah.
Well,
That's
that's
just
an
possible.
API. It's probably an API.
Yeah, in web server you have a JSON API to which you can get live data and check it like every 2 minutes if you want and just scale.
I think
Combination
Scale
of
up and
both
down.
things. I mean, it's very specific. So when you say you need to scale, what does that actually mean? Does that mean database connections? Does that mean CPU? Does that mean disk space? Does that mean
Maybe the response time.
response time? It's kind of like multiple different reasons to it. And you know, sometimes you might be able to leverage Elixir libraries to get that information for you, or you might be able to just leverage.
It's very very well solved by cloud providers by themselves. They have monitoring tools, so you can add a lot of alarms to scale up or scale down.
In the case of auto-scaling, for example, how you will manage the graceful shutdown of a node to say, don't take new messages, please finish the queue, then shut down. We have a way to set this.
No, that I know. Because when you shut down the machine, it just gives some time to the process to die, and if not, it kills.
Like we keep receiving messages.
Yeah, until it dies. The idea of this is that when you create a distributed application, you need to take care of what happens if I don't get a response past it, I don't know, 10 seconds, 20 seconds, whichever is your limit. Probably you will need to send it again.
You can't like just close a link between processes.
I don't know, but I think you can't because at the end, the only thing you have from the other part of the cluster is a PID. And the PID are global, you cannot say this PID is not available. There is an Erlang configuration, which I didn't mention, that is that you can connect to a cluster in incognito mode. So the other nodes of the cluster don't know about your processes, don't know that you're connected. And that's very useful. For example, if you have your cluster in production and you want to connect to the cluster just to get to run the server and see what's happening. But if you do that, you don't want to get load to your observer node. So, I don't know if you can set that when you are running the node itself. Maybe that's a way if you can.
In practice, you probably find that you've always got an external protocol which is going to have acknowledgement. So it's
Yeah.
going to be
Well, you can always, for example, if you are inside a pool using the pool module, maybe you can get out of the pool, finish your work, and that's it. But it's very hard to do that while scaling up or down because when you scale down, your application just the machine just shut down. So,
I have a question about your user. One, when a user or customer is configuring his takes some time. When where do you store this state in case the node is connecting currently, dies, for example? Are you storing this in the browser of the user?
no, it's persisted on the backend. So
Database or maybe ES server? So
it's persisted in the backend. So if a node dies, it will just reconnect to another one and recover its work. In fact, we using channels, it's transparent to the user. So
There is a framework for reliability, reliability, or because or you have to manage your applications. For example, if you have a process that has a queue and it dies, all the messages are lost, then how do you manage it? So the application has to deal with that, or
Well,
is this a framework?
if you have a queue of work, for example, you can use GenStage, which Andrea showed us in a previous meetup. That I think it takes care of what happens if a work is not processing.
It's not guaranteed though. So
If you have your application customized,
no, there are third-party
Implementations for that.
So if you know, assisted in a database or
Redis or
something
something like that.
Yeah, Redis, for example, to get the true reliability. I mean, if you, I think it depends on how what problem you have. So if you don't really, if a process can go away and reload its own state from an external source in order for the business to function, then you need to do that. But if it's not so important, you're not too worried about the process and losing this information, then you can just do the basics of it. Because I think Joseph was answered that himself. A very similar question was asked at the last exam. We provide all of these tools because we're going to the process dies, but it dies.
You can create something on your own to try to, but it's much more easier to use third-party tools that are proven. So
You mentioned that if the tool works to solve the problem, is there any other thing that you found solve with Elixir or Erlang and you prefer to just use another tool? Something that you found that it's not worth trying, let's use Elixir. Something that you found.
So the question is, have we got into a scenario where we've opted for a third party to just do it as opposed to implementing it ourselves? I don't know. I mean, if there's a third party that's already done it, I'd say.
So far has solved your main problems. Because
It's a combination of various different things. You know, if we need a system database, then we just use Postgres. If we need in-memory store to kind of speed things up, then we use ETS, which is Elixir. So I think it's just a combination of trying to look at the problem that you're trying to solve and see if there are good ways to do it. As a general rule of thumb, we try not to use too many external libraries and try not to, we think carefully when we're having a new piece of infrastructure. But, that's kind of balanced with, do we add a new piece of infrastructure, or do we try and, reinvent the wheel? But I think another question which was probably asked about Phoenix is, Phoenix versus Rails. And the whole, Rails has probably everything you want to do is already a gem out there. And, whereas Phoenix is fairly new and, can you solve everything as easily as you can in Rails? I would say we haven't gone into something that would say, fuck, this would be so easy in Rails, or fuck, this would be so easy in another web platform. We haven't ever had that problem. So, the original kind of academic problem more than the reality hasn't really had this at all.
So for common things like process or libraries or modules,
Braintree, brain processing, would never even think about doing that.
Mandela mentioned for
MailChimp, there's libraries for handling MailChimp. PDF. Some libraries as well.
It's pretty mature.
Yeah. I mean, a lot of our rendering side of things is done in Mo, do you want to add anything to that?
Yeah, also remember that Erlang has been around for lots of years. Like any library that's from Erlang.
Yeah, that's true. So Erlang is extremely mature. So there might not be a specific Elixir library, but you can just go over and lean on
Like most of the libraries we saw here are Erlang ones.
Does using Phoenix with the channel management, does that replace load balancers?
No, because at the end the HTTP requests are attended only by the node that received the request, so you need to have a load balancer there in front of your nodes.
Overload, but you can access any channel from the node.
Yeah.
But it doesn't group the requests to the node of the node's node.
And it depends on your load balancer configuration. The important thing about this is that with Phoenix, the node you connect is the node that have the connection. So you also need a load balancer. You can connect always to one node, but it will be like having one node for the web service and the rest of the nodes for backend jobs. But I don't know if that makes sense. It depends on the situation, maybe.
So all the nodes can do to the channels.
Yeah, so I'm wondering,
You need
because
to know.
if the channel's only running in one node, and your routing layer doesn't know about your Erlang Elixir setup at all, then how does the request get routed to the correct node of the channel?
The HTTP request can go to any node. It depends on your load balancer. You have session stipends or not, or
But a message to the channel, if it's only running in a single node, it needs to go to the correct node. So how does it get routed?
I don't know the deepest implementation, but I think when you send a message, it is sent to the PubSub application, which is monitored by PG2, which is like a broadcast system. So when you send a message to a broadcast message to all the channels, it gets to PG2, it distributed to all the PubSubs, and the PubSub distributed to.
Okay, so any
I don't know.
WebSocket connections would get routed to PG2 first and then on to.
I think that PG2 send the message to all the PubSub to all the PubSub processes, and they decide if they deliver the message or not. But I don't know. That's what I think is happening.
Right.
Yeah. It's much easier that all nodes knowing which group they.
Yeah, much easier. Yeah.
Okay. I think we're going to close it down, mainly because I need to rush on and block the office. But normally we go out for a drink afterwards. Even if somebody's going to be going, you've got to run today. Anybody up for a drink? Yeah. Stick your hands up. Work out who you are, and then maybe you can just decide that. There's 2, 3, 4. A couple of people going up for drinks. Yeah. Cool. Thank you very much.
Thank you.
Can I just ask you to pick up